To the oilman, the importance of the North Sea today lies as much in the technology required to extract the oil as in the oil itself. For the British, this technology, much of it once imported, is now being developed at home. Matt Linning, General Manager, UK Offshore Development for BP, explains.
Merely that in the beginning, so to speak, none of us appreciated the great difficulties. And the appreciation has only come over the past few years. This not only to the British people involved, but all the contractors from different countries, America included. Well, of course, we have a long history of expertise in engineering and associated fields. So it has been more a question of redirection, reorientation, rather than basic learning.
Redirection, and in some cases, wholly new concepts, such as at Howden in northeast England, where William Press Production Systems have designed and built a specialist yard to produce equipment modules. The unique feature is the module assembly pad, with a remarkable maneuvering system based on friction-free PTFE, which permits accurate movement of the heaviest modules through all production phases. 2 fully equipped workshops and overhead craneage can be moved to any location in the yard using the same PTFE system. The system allows for completed modules to be hooked up as on the deck and given thorough tests for structural matching and systems functioning. This facility is particularly useful since any problems can be corrected at the yard, not on a remote and exposed platform lacking full technical support. Redirection and reorientation aren't limited to the construction side of the industry. All aspects of the contents of the modules have also received attention. One example is Rolls-Royce, the world's major supplier of marine gas turbines. They have adapted their experience directly to offshore operation in producing the new lightweight SK-20M compact generating set, powered by the versatile Olympus engine. With over 260,000 hours of marine or industrial use, this engine accepts a wide range of fuels and offers great flexibility of operation in all conditions. The British have known and respected the hostility of the North Sea for centuries. It has prepared them well for the massive research and development required for platforms such as this, Graythorp 1, constructed by Lang Pipelines offshore for the huge BP Forties field. The Graythorp yard and Teesside provides good deep water access, 1,500 skilled craftsmen and excellent air, sea and rail communication. A flowline principle links this access to storage, prefabrication, welding, shot blasting, painting and assembly areas. In the main basin, the 2 giant cranes, reputed to be the world's largest of their type, attain a jib height of 400 feet and a lifting capacity of 800 tons each. The concrete caissons provide permanent dock gates which can be floated clear to allow passage for structures up to 400 feet in width. Graythorp 1 and her sister Highland 1 have now been successfully placed on site, and 2 more are under construction, the largest metal structures ever made. Almost every stage of their construction represents a new first, another milestone passed, another barrier broken in terms of oil technology. Large platforms call for large modules. Foster Wheeler John Brown boilers have developed 2 assembly yards at Hartlepool and Dumbarton with ideal waterfront locations, loadout facilities, a skilled workforce and expertise in design, management and computer planning. The Dumbarton yard recently witnessed the completion and loadout of 3 modules destined for the BP Forties field. 2 of these, the largest yet constructed in Europe, weigh 1,750 tons each. Over the last few years, the base for North Sea exploration has centred on Scotland and the northeast of England. Apart from the geographic relationship to many of the new discoveries, the bays, lochs and inlets provide the ideal sites now required for the construction of production platforms. 14 sites are now available, with a further 8 should the need arise, sufficient for all projected North Sea needs. At Ardine Point, the Robert McAlpine Sea Tank Consortium are building concrete gravity structures. Linked directly to the industrial and commercial River Clyde Basin, Ardine Point admirably fulfills all the criteria governing such a site. Offshore, there is a weather-protected basin with ample water depth for the completion and towing out of the largest structures. Many of the materials required can be brought in directly by sea in bulk. Gravity structures, with reinforced concrete as the main structural material, offer effective and economic answers to many of the problems posed by the North Sea. They can withstand, without anchorage or piling, the action of the most powerful wind or waves. Concrete itself is immune to all the corrosive onslaughts of these waters. Such structures can be placed in position in 24 hours and have the added bonus of offering substantial oil or gas storage space. Already the first platform produced here has been towed out for completion, and already it's dwarfed by the platform next to it, the $60 million Brent Sea platform for Shell Esso. This platform will weigh nearly 300,000 tons and be capable of drilling 36 wells. The cellular egg box type of base caisson with 36 compartments will permit selective and gradual ballasting during towing and installation when immersion takes place. The central cells will eventually be used to store 600,000 barrels of oil. But this platform is now only the second largest offshore structure ever contracted for. The giant 333,000-ton Cormorant platform will drill up to 42 wells, store 1 million barrels of oil, and serve as the main pumping station for 5 fields for the pipeline to the Shetlands. The technology involved in such structures represents a giant step for all oil men everywhere, but especially in Britain, where the offshore oil industry has grown to global stature in just over 5 years.
Already British consortia are working on new ideas, not for next year, but for 5 to 10 years ahead, for even deeper water. So in the design and expertise field, I think we'll be well to the forefront. I think what we're going to get out of the North Sea in the global sense is this is the most tremendous training ground in the world.
A training ground in which the frontiers of technology have once again been rolled back, opening the way to new areas of search in deeper, more turbulent waters. The requirements for developing these new areas remain uncertain. But whatever the challenge, British technology will be ready to meet it, not just in the North Sea, but wherever the need arises.
End of final, meeting the challenge, North Sea.